Okay, I think we've waited about long enough. I'm going to get started. Yeah, cheers. Well, I'm guessing everybody else can have a little look at this in their own time as they've not joined in for the live stream, but I'm going to go ahead and start the paper with who's here. So, let me just make sure you have your paper. So, question 1 looks at this algorithm here, and it just looks at just these two basic computer science principles, selection and iteration. So you need to be able to define what both of these are. Selection is the one which most people get wrong. If we look at this, piece of code, selection is this portion here. So selection is kind of the condition and then the part that happens afterwards. So this bit here, if key pressed equals player key, then position equals position plus 1. This is actually our selection statement. So it's a condition used to decide whether or not something should be executed. So layman's terms, there you go. So a condition used to decide if code is run. And the example you could give, you give the whole thing there. So if key pressed, da 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 da, da, and then the position equals position plus 1. Okay, so that's selection. So just remember then that selection is not about selecting one of something. It's about this condition. So if the condition is true, then something will happen. That's what selection is. Iteration, most people will know because that's pretty straightforward. Because that doesn't really change much from the sort of the general meaning of iteration. It means to sort of go over and repeat something. So iteration is a code which is repeated. So executed and repeated. So it's basically a loop here, okay? The example that you would give from this code is basically until position equals 100. So you've got repeat until position equals 100. So repeat until position equals 100. Okay, and there's your selection and your iteration defined and with examples there as well. Okay, a couple of quick and easy ones for you. I've said this a number of times, but you will always get a question about data types. Okay, so you need to know them basically. You need to know the difference between them, but you'll usually get a table like this or something like that. So if you look at this question here, when customers pay using a card such as the one below, shops use computer systems to process the payment. Tick one box in each row to show which of the data types given is the most appropriate data type for each of the following data items. So the first one here, the amount paid, because this is going to have a decimal point in it possibly, this is going to be real, because we know, yeah, real means float, so real is the same as float basically. The customer's card number, this is going to be the customer's card number, it says it's going to be going in as a string. I don't know why that would, but actually probably because of the spaces actually, it would go in as a string I suppose, or these would have hyphens between it. So the customer's card number is going to be going in as a string, and then when the payment is made, that's obviously going to be going in is going to be on the date. Integer mistake on card number. Yeah, it's a bit of a weird one this, because the mark scheme does say that the card number is actually a string. So I'm not 100% sure why it would go in as a string. The only thing I can think of is the fact that there are these spaces here. Okay, so obviously as the spaces are not numbers, they'll need to be processed as a string. Bit of a trick question there, I think, actually. But when the payment's made, that's going to be your date. Okay, so just bear that in mind. But if you get a weird looking card like that and you need to think, okay, is it going to ask me to consider the spaces, which are actually letters or strings. Okay, number 3. This is another straightforward one. We've done this flowchart a number of times now, but I just wanted to go through these ones here. So these are the data types. Okay, so gender. Gender data type. Do we know any ideas what the data type for gender would be? Just comment it if you think you know it. Or not. So Boolean is only yes or no, so that would only be, so that would not be for gender. Int is obviously only for numbers. Okay, so again, that's only going to be 1 or 0. I'm looking for the data type which handles letters. There we go, string. Thank you very much. So string is going to be our first data type. Okay, the dose, so the amount of dosage that we're going to be given to the patient, they can have, as we've done this several times, we know that the dosage can have like a 0.5 to it and things like that. So we know the dosage isn't just a whole number. The dosage here is going to be real. And then is pregnant is either going to be yes or no. So yes or no for this one. Any ideas? Data type that just handles yes or no. There we go, Boolean, well done. There we go. Is there a difference between float and real? Not really. Float is just the term used when actually programming. Real is more like a general overview term for that. So real is like the theoretical term for it, and float is what you'd program it in Python, for example. There may be a different programming keyword for it in a different language. Okay, let's have a look at this one. Something a bit more interesting. So this is worth 5 marks, this question. You need to write an algorithm which takes 3 inputs and it looks at those inputs, it compares them, and it tells the user whether or not the triangle is an isosceles triangle. So I don't know if you've seen Silicon Valley, but it's kind of like that the hot dog program that the guy makes. So is a hot dog or not hot dog? This is exactly the same. So is an isosceles triangle or not isosceles is basically what we're going for here. So where do you actually get these marks from? Well, in order for the program to run, we need to input the 3 sides to begin with, and that is where you're going to get your first mark. So you're going to input side 1, input side 2, input side 3. Okay, and I'm just writing this out just as normal pseudo. There's nothing programming about this as such. I could do arrows here if you wanted to do pseudo like that. You're not going to get marked down for this, for not having those in or anything like that. So that's where your first mark would come from. You've identified that the user needs to input all 3 sides. Now the next part is there's 2 different ways you can do it. I think we're going to do it the simplified way. But you get the next mark for when you compare the length, but you have to compare them in pairs. So you need to compare 1 against 2, then 2 against 3, and then 3 against 1, and then you've made all of the comparisons. So you would do if side 1 is equal to side 2, or side 2 is equal to side 3, or side 3 is equal to side 1, running out of space, then we would output, or print, output, whichever you want, print isosceles. Okay, so this part here is where I'm getting the marks from. So in order to do this, I don't need to do this all as a big or. I could do this bit first, and then I could do another one here, and then another one here if I wanted to. But I'm just doing this as straightforward as I can. You know how to use these or statements, so use them in your exam, because they're going to make things a little bit quicker, a little bit easier for you. So you get 1 mark here for the comparison. So you've done all the comparisons right. You've compared this side and this side, this side and this side and this side and this side. You've used selection, which is the if and the print here. And then you get, you don't get all of the marks just yet. Oh yes you do, sorry. You get a mark here for printing out the fact that this is an isosceles. That's 3 of the marks so far. Else. So this is basically when that's not equal to that, we're just going to print not isosceles. Okay, and that's straightforward there. So you get you have, out of the 5 marks here, we have 1 mark here for this, another mark for that, that's 2, 3 marks for that. You then get, you get a second mark. So you've compared these, and then you've done all 3 sides correctly. So you've done the comparison, and then you've compared all sides, 3, the comparison there, and then this final print to make sure it's not isosceles. No, there's no need to make sure there's not an equilateral triangle. Don't do anything that the question's not asking you to do. It's asking you for this and this only. Okay, and that's it for that question. That's pretty straightforward there. But like I say, if you don't like this bit here, you can always do it like this, and then you would do an elif and an elif there to do your other two checks, basically. Right, and we now have the final question, or the final 2 questions, because this is like a 2-parter here. So this is pretty straightforward. You'll get a nice, easy softball like this one. So if the name of player 1 is Helen, player 1 is Helen, who is player 3? So player and then 3. So we look at the 3. This is going to be Lydia. Straightforward. What will happen if the code for the game includes an instruction to print the value player 7? Well, It doesn't go up to player 7, it only goes up to player 6. We're going to make some assumptions about position 0 being used as 1, and we're not going to consider that too much at the moment, but basically it's saying if Helen is 1, we're basically going to get a syntax error, correct? The way to write this one down then, just to make sure we get all of the marks for it. So it finds, so there's no position, so no position 7, so we're like basically out of bounds. That causes syntax error, which then causes a crash. So it causes the program to crash. All right, so that's pretty straightforward. You probably would have got the marks there. You probably got the marks there just for saying that it's causing a syntax error because there is no position 7. That would get you the marks there. Now, this is the interesting one. This is the good one. So this is probably the one which is the hardest. And actually we're going to need this diagram just to help explain it. So what we've got here is a question that says, during the game, each player sometimes moves clockwise by a given number of places. For example, if the number of players is 2, Helen will move to seat 3. If the number of places is 2, Helen moves to seat 3. Priya will move to seat 1, etc. So basically it's saying if we're asking to move round a certain amount of places, if the certain amount of places to move round is 2, Helen would move round 1, 2, so she's now in position 3, and then Adam would move round 1, 2, so that's now in position 4, then Lydia would move around 1, 2, so they're now in position 5, and so on. So you need to make a program which takes into consideration the amount of times it's going to rotate, so 1, 2, 3, 4, 5, or 6, and then applies the new positions to each of the people playing. All right. So it sounds a little bit complicated, but I'm going to explain how it works. So what do we have here? So write an algorithm that will update the contents of the array player name after the move has occurred. Your algorithm should do the following. Allow the number of places to move to be input, so you know where the first mark is going to come from. It's going to come from your input. Use iteration, so you're going to use some sort of loop in here, and ensure that all the existing players' names are moved to the correct position in the array. That's going to be the thing which is going to be probably the more difficult bit here. Okay, so what we're going to do, basically what we need to do is we kind of need to turn this like a clock face or like a cog. So we need to create a program which shifts the whole thing round by 1. So it's going to go 1, so that'll be, if I wanted to move every player around 1, I could run the program once, it shifted once. If I wanted to move the whole thing around twice, I would run it and it run once, and then loop round and run again. So basically I want a program which swaps this position for this one for this one, this one for this one, this one, and so on. And then it just keeps, and then the loop will run for the amount of times that I want it to run. So how do we do this? I need to, if we look at this, I need to be able to do that, I need to move Chan into Helen's position, okay? I can't do that unless I move Helen into Adam and Adam into Lydia, but there's always going to be somebody in the position before I can move anybody into the position. So I need to create a temporary variable, okay? So what will happen is I will move Helen into the temporary variable, and then Chan will go into here, and then that will then allow, so if I move Helen into the temporary variable here, it'll go, I need to go the other way around, so then Adam will go into here, and then Lydia will go into there. That's going the wrong way around though. Well, let's start writing it, and then I'll figure it out as we go. But we need to create a temporary variable which we can move one of these positions into, and then we can start sort of clicking the whole cog round. All right. So first things first, let's work on the input. So I'm going to input none. Okay, so this is just going to input the amount of times this is going to run for, and then I just need to do like a quick range loop. So something like for I in range, and then I do from I to none. Okay, so this is going to run from my starting point to the amount of times that they've put in there. Okay, and then all I'm going to do is I'm going to create my temp variable. So temp equals player 6. And then, oh, that should be indented. I'll do that bit again. So temp equals player 6. And then the position player 6 will then equal player 5. Player 6 will then equal player 5. Oh, okay, so it goes around that way around. So then we will do player 6 equals player 5. And then we go backwards on ourselves, so player 5 equals player 4. Will you lose marks for not indenting? If they can see that what you're trying to do is actually kind of within a loop and it's quite clear what you're trying to do, I don't think you would particularly lose marks for that. You'd have to be a pretty harsh examiner to take marks away for that. But just to be safe rather than sorry, it's good practice to make sure you do it, okay? Because it's very evident then that this is my iteration. Okay, then player 4 equals player 3, player 3 equals player 2, player 2 equals player 1, player 1 then equals temp. Okay, so using this, I can switch my players around. So player 6 goes into temp, then 5 goes into 6, 4 goes into 5, 3 goes into 4, 2 goes into 3, 1 goes into 2, and then position 1 goes into the temporary holding position for the time being, and then we can move that back in after. And then I just basically next I kind of thing, but you know, next I, this portion at the top sort of takes care of that. The for loop here and the fact you've got from here to here, this takes care of the amount of times that you're going to run the program. All right, so have a look at that in your own time as well. See if you can get that sort of working in your own head. That's a little bit of a strange concept to get your head around if it's the first time you're looking at it. What you would get the marks for here, it's at a 6 mark, so you get your first mark for the input statement here at the top. You get another mark for the correct use of temporary variable, so that's your second mark there, or whichever one there. You would then get another mark for the sensible use of a loop, so this is a very sensible loop that we've created. It has a end condition here, so this is our ending condition as well, because we're saying from here to here, and then it's going to end, so that's giving us 4 marks. Correctly deals with moving the positions, so each position has been correctly moved here, so that gives us the 5th mark. And then correctly deals with moving from position 6. So the fact that we've started at position 6 and gone the other way around, that's going to get us our 6th mark there. Okay, so have a look at that, see how you get on with those. Make sure you have a look at the other videos, which go over the other exam questions, because there are only, what is it going to be, 2 weeks and 2 days until the computer science exam. So make sure you check up on those, make sure you're working on those, and we'll do another one of these next week. All right, thank you.